Yes, more antiderivatives. Okay. So basically what you're looking at is you already know derivatives. We're just adding a few more antiderivatives based on the knowledge you already have. So if you remember that derivative,
oh, that's the x.
Right? No, that's a derivative.
Oh.
That means that the antiderivative of e to the x is
E to the x.
e to the x
Oh, we're so good.
plus a constant, right? So again, you already know the ones we're going through today. It's just a matter of putting that in your mind and using them appropriately. Because I know sometimes we've done derivatives so much that you look at an antiderivative and you just automatically calculate the derivative on accident. Okay, so that's probably your biggest issue. That's my biggest issue this time of year, is I just automatically try to calculate the derivative. But just keep the difference in mind. What about the derivative of natural log? Yeah. Okay, so what's the antiderivative of 1 over x?
Natural log. Dude, this is what my boss told me.
There's one little thing you have to remember here.
X natural log.
Does natural log allow for negatives? No. Okay, so we have to make sure that's not negative. Because this can be negative here. We can have negatives, so we have to do absolute value. We'll get to the point where we start putting numbers here. And it gives us some really neat stuff to calculate. Okay, e natural log, I think we've got about this. Yep. And then all the trig functions apply as well. The derivative of sine is cosine, so that means that the antiderivative of cosine. Yep. So again, we're using that to our advantage.
Question. So if it was negative 1 over x, would you just ignore the negative at all? Like entirely?
You are asking about that?
Yeah. Just ignore it. So,
It just travels. It's a constant. It's -1, right? Same thing here. If you have negative cosine, this becomes negative sine. Right.
So you just can't have a negative x value.
We can't have anything else.
Oh, you can't have natural log. That can be negative, but you will absolute value that and make it
that's what I was
positive.
saying. So like if it is negative, just
Yeah, if there's a negative number in there, just put the negative in.
Yeah.
Because the absolute value will take care of it. Don't worry about it.
We asked you our question.
They asked me a question when I was still taking exams.
So do I need to write down cosine? Yes, I do.
yeah, because isn't it?
Whoa.
No, it's not different. What's the derivative of cosine?
Negative sine.
Okay. What is the antiderivative of sine x?
Negative cosine.
Cosine.
Oh.
Is it negative? Ooh, gone.
Yeah, so just know that this relationship imparts a negative either direction. Because you end up with a negative sign for the derivative, but when you are asked for the antiderivative, it's usually positive.
Okay.
So the result has a negative on it. It says cosine x.
Well, I thought it.
Right?
That was a good one.
Looks like it's some names.
Okay. So we could also do
These are all going to be different colors.
the integral of secant squared.
Oh, and
They're like
Yeah.
gross.
-10. -10.
no.
10 I'll give you. But it's winter in Colorado.
Please don't.
Oh, yeah.
plus C?
Yeah. There's no squared, there's no negative. Remember, because the derivative of tangent is secant squared. Okay, could we also go through cosecant, cotangent,
Yeah.
secant? All those apply. Do you want me to write them down?
No.
Are we gonna put them
We'll
on
put them on
cards
note cards
eventually?
anyway.
We'll put cards together.
Oh,
Yeah.
and
Okay. All right. Okay, let's do some examples here. Okay.
Such a pretty problem.
Is that,
They're not hard, they're like, they'll make everyone cry, but.
3x to the 1/2. Wait, no, 3x to the negative
Okay.
1.
In derivatives, you are instructed to rewrite this as a negative exponent.
Right.
But here, what's the antiderivative of 1 over x?
Natural.
Natural log. So we just leave it.
Wow,
Okay,
that's
so this is 3
natural log.
natural log absolute value x. It's this here.
Okay, right.
And then what is that antiderivative?
Oh,
Add 1. Yeah, negative 9.
Over negative
Divide by plus constant.
I always try to do the power rule and multiply them. Every time.
Okay. We'll get used to not doing that unless you're doing a derivative. Okay. Do you understand that?
Can you do that problem even if you like switch it to 3x to the negative 1?
Well, it's the same. It's the same result. It's just easier to see. Okay, so there you go. What about this one? Yeah.
that wants the antiderivative.
4x.
oh yeah, plus.
Okay. You can put equal signs here. All right, so we're still working it there. Cool. 5. Okay. So you're okay so far with those antiderivatives?
Yeah.
All right.
The negative 5x to the negative 10 to the negative.
What if I asked you for the derivative of e to the 5x plus 4?
It'd be equal to x.
No.
It'd be e to the 5x plus 4 times 5.
Times 5, right? So 5e to the 5x plus 4, right? You got a chain rule?
Right. Oh, that's
Okay. What?
We're doing the are we doing the derivative now?
That was a derivative. Yep.
Yeah, the notation.
Anybody confused about that derivative? Okay.
Why do you multiply by 5?
It's a chain rule, because we have the derivative of the outside, copy the inside, derivative inside. Dos side I, remember? Okay, how do I deal with that situation in an integral? Right, so I've given you that derivative, right?
Right. So then it
Yeah, but I've got a 5 there. Why does it disappear?
Because you divide it by 5. Divide by 5.
Yeah.
So where are you pulling the 5 from?
Where does this come from?
Yeah. The constant in front or the 5x?
But because it has to equal.
Yeah. Okay, there are a couple ways to remember
If
that.
you didn't have the derivative, we wouldn't know what it
It
actually
has to equal back to the original.
Yeah, so that's one way to think about it.
Okay, so you can do that.
So you have to go back to the original, right? The way that,
If we don't have the original, how though?
exactly, the way that I remember it personally is to divide by the derivative
Of the X.
of that value right there. Yeah.
So if it was, what would happen if it was like 5x squared 4x?
We'll get to that later, much later. It's, there are ways to deal with it. One of them is called a calculator. And the other one's called substitution or integration by parts. Okay, so let's talk about one of these without the 3 in front. Without a constant out here. So it's e to the 3x minus 2 over 3 plus c.
Because you have to divide by the
Divide by the derivative of the X on.
So if I derive this,
Oh.
I'm going to end up with a 3 out front by the chain rule. Divide by 3, that gives me 1, which is back here.
Right.
Correct?
Right.
So you can always check your math by doing the derivative. Okay. We can have, are you okay?
Yeah.
Montaigne's texting again.
Oh.
Hopefully it's not a teacher
Right.
or his boss. Damon.
Oh, he's probably gonna do it. Are you gonna do one with like, so it's like e 3 to the x squared
No.
minus 2? No?
Because
Well,
you
then
cannot,
over
you
half.
cannot use this unless it's just linear.
Okay.
The x squared brings another x into the mix. When you derive x squared, it's 2x, right?
Right. So you can't have
No.
that, okay.
Just don't worry about that. All you're going to get's linear for now, okay?
Thank you for showing me.
You can apply that to the trig functions as well. So the derivative of sine, or antiderivative of sine is?
Negative cosine. Negative cosine. Negative cosine. Why is there a key?
And what do I have to do?
Add it.
Divide by 2.
Divide by 2.
Divide by 2.
As p. Okay, got it.
Yeah.
Right, so it's the same situation as the e. if you have a linear function inside of sine, cosine, and the exponent of e, this is how you deal with it for antiderivatives. And then again, if you need to, you can check your work by deriving this to get back here. Okay. Do you want me to show that to you, the derivative of this?
Yes, just so we know how to do it.
Right. D over dx, negative cosine 2x plus 1 over 2 plus math murder. Here's the chain rule problem. What's the derivative of cosine?
Sine. Or
Negative sine. So you have the negative of negative sine. Copy the inside. Times 2. And the 1/2, the 2 has to travel. Plus c? No, math murder. Derivative of a constant is 0. Does this simplify to our original? Yeah, it does. Okay. So you can always check yourself so you don't wreck yourself. Or your mathematics grade.
It's already red.
I have a 2.1.
Actually, that's true. You called it, thank you.
Like my
And
wild.
I'm proud. But,
All right, if you can handle that
no.
series of calculus, antiderivatives, derivatives, then you're good for the day.
Okay.
All right?
Like in the jungle.
Yeah, there's not very much of it, so
Thank you.
every day.
Dude, what's funnier is like he just responded. And like you thought it was him. Yeah, and like he did it with like more advanced stuff than we already learned.
There you go. Yeah, he just doesn't know where you're at.
Well, because I did the wrong problem. It was the natural log x one where it's like x to the -1. So you gotta write it.
Where was he your boss?
Huh?
The pool, right? He does calculus.
Yeah.
Fantastic. I bet he had to take business calc.
And like he was using like even though